Hey everyone, our team name is BYTE Me, and my name is Joshua Howell.
My name is Hayden Viescas.
I'm Kylan Rayner.
I'm Julian Rivera.
I'm Spencer Gilbertson.
I'm Aiden Relier.
And I'm Nixon Reyes.
And this is our group project. So, for the why, the first reason for that is the hands-on learning. Designing a Lego car allows us to combine creativity with technical skills, offering a tangible application of engineering principles such as kinematics, mechanics, and mechanical properties in a simplified, manageable form.
This project also helped us improve our CAD skills in SolidWorks. By using SolidWorks, we were able to model a Lego car, which gave us the opportunity to enhance our proficiency in 3D modeling, which is an essential skill for mechanical engineers. This project challenged us to think critically about part assembly, tolerances, and design constraints.
Another important part of a design process like this is the iterative design process. And because Lego pieces are as modular as they are, it kind of aligns with that whole process. It allows us to quickly modify and refine our design. It also allows us to test various concepts and explore different optimization techniques. So if we wanted to say change the size of the spoiler or maybe change the front lip, it's easy. Also, the modularity of the design forced us to work on our team collaboration skills. So we had to each know exactly what we were doing. And this promoted teamwork and communication with our group. We also had to collaborate and utilize each member's strengths in design, analysis, and CAD modeling.
So why did we do this project? It's engaging and fun. A Lego car presented a unique and enjoyable challenge, making the project more engaging. This helped us stay motivated and think outside the box, along with having fun and still achieving our engineering learning goals.
All right, this is an assembly of the Lego car. This is what we built. I think this is the rendered version. Uh, and here is the exploded view of said assembly.
So this is our final assembly with our exploded view and the standard parts list. There's bubble to every part, and then that corresponds with the table we have on the right.
So this is a video of our Lego car being assembled like it would be in a Lego video game.
I don't know why it's playing twice. Okay.
And so now we're going to take the opportunity to talk about the different pieces and parts that we each designed. So starting off with the 2x2 brick, this was the first block that we designed for our assembly. Um, this block was a literal and figurative building block. It taught us a lot of the patterns that we would be using um, for the later pieces of the assembly, and it also gave us a reference for the dimensions. And the SolidWorks tools used for this 2x2 block were the boss extrude, the center rectangle, and the circle tool, the shell tool, and the linear pattern tool. Um, and then for the next part of the base plate, this was the foundational piece of the car assembly. This was the piece that gave the team a foundation to expand our ideas upon what kind of pieces we'd like to add on to the car. The base plate was revised twice due to misalignments with other pieces that caused a need for the base plate to be revised. And the tools used for the base plate were the boss extrude, the corner rectangle on the circle sketch, linear pattern, the mirror along an axis, and the shell tool.
All right, so the next part, or parts, I guess I should say, are the doors. So looking at the left door, there's a few design considerations for the door. First, it kind of had to fit the whole style of the car. Didn't want to look out of place. It needed to be functional, so handle needed to be able to rotate in and out, and work within the given boundary again, so it doesn't stick out of the car, make it look weird. Um, the tools used pretty simple: boss extrude, a mirror for getting the left and the right door, and the boss cut. And then for the right door, pretty much the same thing.
All right, so here we have the steering wheel base, which acts as the mounting point for the steering wheel itself. Um, when designing this, we had to consider both the height and then the tilt angle of where the actual steering wheel attaches, just to make sure the wheel was as ergonomic to the driver as possible. And the tilt especially adds to the comfort and mimics real driving positions. A key challenge with this was making sure that the hole at the top of the base aligned perfectly with the center bore on the steering wheel. So to do that, I used reference geometry to make sure everything was centered and accurate. With this, building it was pretty simple. Used the boss extrude for the base, the shell tool to hollow out the bottom to give the room for the supports and to make it that Lego-like. Nextly, we have the steering wheel. To do this, we went with a classic circular rim paired with a three-spoke hub, which balances simplicity with strength. The center bore allows for the mounting to the base, and the whole design focuses on symmetry and comfort for the user. The steering wheel was designed so it can be easily interchangeable or swapped out and upgraded with any other steering wheel. To create this, again, it was pretty simple. Didn't use too many new tools, just used the revolved circular pattern and fillet tool. Overall, these parts helped us in the project with focusing on real world usability, integrating that into our parts.
This is the seat for the Lego car. This is where the Lego minifig would sit in the car. The main challenge of this part was the backrest of the seat is slightly angled back. So this was revised once as because of that angle, it was going into another part. So that had to be fixed. Um, didn't really use too many new tools, just a shell and some fillets for the curves.
All right, so this is the rear axle. It's actually one of two pieces on the assembly. Um, to make a long story short, this was designed to support the wheels and the pieces that are going to be placed on top of it. This particular piece is going to be sitting on top of the base plate. Basically, to make a long story short as well, for again, a couple of tools were used on this one, such as the mirror, the extrude boss, and offset entities. Making the sidewalls was particularly one of the most challenging pieces on it. But once I figured out how to use the offset again, it made this a lot simpler.
So this is the rim. We improved the internal design of a normal Lego rim, and it attaches to the axle. So the main challenges were trying to get those inner spokes. Tried using rib tools, but it wasn't working too well, so we tried using the loft. And the loft gave it this very nice turbine-like look, but it also took a very long time to learn how to do. It basically attaches two different parts of two different drawings on different planes with the use of a guide curve. So it gives it that really nice arched look. And then this is the tire. It slides over the rim. We changed the tread pattern from a normal Lego tire to be more realistic and increase traction. It can help push water away to prevent your Lego car from hydroplaning, because that is such a big risk with Lego cars. And then some of the challenges were getting the tread pattern into the tire. So this required new tools such as surface revolves, which allowed us to take a line and create a circle from it, so that we could extrude cut the tread pattern into the surface of the tire, and then circular pattern that around the entire tire, which happens 36 times for this tire.
Block for the front brake, we decided to go with a 45-degree slope in the front to give it a more aggressive front end to match the rest of the car. We designed the front brake along with the front lip that would go under it. The SolidWorks tools used were the straight line sketch, the circle sketch, the boss extrude, and the shell tool.
Okay, so for the next piece in the assembly, we have our 1x4 plate. This was designed to be the front lip of the car, and it was designed to attach up under the front brick, which was the previous part discussed. This piece was designed to be interchangeable with other bricks, such as different colors as well. That way the car could still be customizable. And with it attached under the front brick, it leaves 2 points on the end of the lip. That way users are able to add additional pieces for further customization. Some of the tools used in this are the straight line and circle sketch, boss extrude, and extrude cut as well.
All right, here's the vent that goes on the front of the car. It doesn't really have much functionality, and it's designed solely for aesthetic purposes. If it were to be a real car, it would improve sound and performance, but it's not. Um, the main challenge of this was actually getting that offset on the underneath and adding the slot right in the middle in order for it to attach.
Figure 18 shows the 1x2 flat handle, which serves a critical part for our function in our design. The purpose of this component is to attach the wing assembly securely to the car's body. What makes the design significant is its adjustability. This feature enables active aerodynamics, allowing the wing to respond dynamically to driving conditions for improved performance. To create this part in SolidWorks, we used a combination of core tools, the extrude tool to build the primary shape, this shell feature to to hollow out areas for weight reduction, and the arc tool to define and curve profiles essential for both function and aesthetics. Figure 19 displays the wing, a visually striking and functional component of our design. Its primary purpose is to generate downforce, helping stabilize the car during cornering. However, we also designed it with aesthetic appeal in mind, as it strongly resonates with our target audience and enhances the overall look of the car. From a modeling perspective, we use several key SolidWorks tools: the chamfer tool to redefine edges and add detail, extrude cut to shape and carve out material, and extrude to build the main structure of the wing. Figure 21 highlights the 1x2 flat hook, another key component in the wing assembly system. Its main purpose is to assist in attaching the wing assembly to the car's mounting structure. The reason for this design choice is supported by the wing's adjustability, contributing to the active aerodynamic functionality of the vehicle. In SolidWorks, we utilized a few central tools to create this part: extrude to form the main geometry, extrude cut to remove the material where needed for fitment, and shell to reduce weight while maintaining strength. Thank you for your time, and we hope you enjoyed hearing about our project. Any questions?